gluconeogenesis. It is the process that allows the body to form glucose from non-carbohydrate sources like lactate, glycerol, and amino acids. Why do we need gluconeogenesis? Our bodies increasingly use gluconeogenesis when our stored carbohydrate sources and blood glucose decline. So the more we starve, the more we rely on gluconeogenesis. This process occurs in the liver in order to produce free glucose molecules that your body uses for energy or to maintain blood glucose levels. Most of this process happens in the cytosol of the liver cell. Our endpoint is glucose. Our main precursors are lactate, glycerol, and certain amino acids. Lactate is constantly being produced by red blood cells during intense physical activity and muscle cells during anaerobic activity.
So gluconeogenesis happens in the liver, and first the pyruvate will be converted into phosphoenolpyruvate. The phosphoenolpyruvate is converted into 2-phosphoglycerate and then 3-phosphoglycerate, 1,3-bisphosphoglycerate, glyceraldehyde 3-phosphate, and then could be converted to dihydroxyacetone phosphate, then over to fructose 1,6-bisphosphate, fructose 6-phosphate, glucose 6-phosphate, and glucose. So the three precursors of gluconeogenesis are lactate, glycerol, and amino acids. All of the amino acids except leucine and lysine. So lactate enters and is converted to pyruvate, and the pyruvate goes to the liver mitochondria and from the muscle, and it's converted to glucose because the muscle lacks the enzyme to convert lactate to glucose. So that's why it comes to the liver. And in the liver, the lactate is converted to pyruvate by the enzyme lactate dehydrogenase. All of the amino acids besides leucine and lysine are glucogenic, so that means they can be used in gluconeogenesis, and they are transported to the liver mitochondria, and then in the liver mitochondria, the amino acids are converted to malate, and then the malate is transported out of the mitochondria to the cytosol, and from then it is converted back to oxaloacetate and then continues down the gluconeogenesis path. The glycerol comes in the glyceraldehyde 3-phosphate and the dihydroxyacetone phosphate, and it's hydrolyzed, and then the fatty acids from the triglyceride are used as a fuel source. Then the glycerol enters into the pathway and is converted into dihydroxyacetone phosphate and leads down the pathway as normal. Overall, gluconeogenesis is used to turn non-carbohydrate sources into glucose when glucose isn't readily available or getting used too quickly. Amino acids, lactate, and glycerol can be made into glucose through gluconeogenesis to keep the body sustained and blood glucose levels up.